So in the today's class, we are going to cover some more problems on step down chopper and step down chopper RLE load. Okay. So we have solved problems on step down chopper, step up chopper, the basic R load and RL load in the previous class. The continuation of that will be today's class, which is having a different type of or a different set of problems, which is based on step down chopper, step up chopper, and then step down chopper with a. Okay. So in the first problem, what I have is in a step down chopper, the source voltage is 220 volts, that is Vs. T off is 1400 microseconds. T on is 600 microseconds. Okay. Now we have to calculate the load circuit parameter. That is, it is a RL load. So it will be having R as 1 ohms, L is 5 millihenry, then E, which is 24 volts. You need to determine whether the load current is continuous or not. Okay. Then secondly, you need to be checking for the maximum and minimum values of steady state output current I0. Okay. Then average load current and peak to peak ripple current. Okay. So you can see here the Vs is given, T on and T off is given, the load parameter RLE is given. We don't know what is duty cycle, we don't know what is the I0 value, we don't know whether it is continuous or discontinuous. Okay. So initially we'll calculate what is called as duty cycle. Okay, duty cycle K is equal to T on divided by T on plus T off. So you add the two, that is 600 plus 400, and 600 divided by 1000 will be giving me 0.3. So 0.3 is my duty cycle for this particular problem. Okay. So this is the first calculation, because to check whether the load current is continuous or no, you need to be calculating what is called as minimum current. Okay. Then the time constant tau, which is defined as L divided by R. So L divided by R will give me tau, which is equal to 5 milliseconds. Okay. Then we have here I minimum, which is Vs divided by R into e to the power 2 times K divided by this tau. Okay. So 2 times K divided by tau minus 1 whole divided by e to the power 2 by this tau minus 1. Okay. Minus of 24 divided by 1. What is this 24? It is your E. Okay. We have R, L and then E. So this will be minus E divided by R. So once I calculate this value, it is equal to 33.03. Whenever the I minimum value is greater than 0, that means we have a positive current flowing in the circuit. Then what happens is we assume that the load current is continuous. Okay. How I am defining this is by your waveforms. Okay. Hope you remember this waveform of a step down chopper with this as the maximum limit, this is a minimum limit, this is capital I1, this is capital I2. Okay. Whenever this capital I2, by the time it reduces, this reduces during the T off. When it reduces and by the time it reaches capital I1 level, at that time if your chopper is in the on condition, that means the chopper is switching with a frequency such that the load current or the current what is flowing through the RL load or the inductive load, if it is continuous, at that time we say that the current is continuous. So to do that, I'll be reducing the value of I2 from capital I2, that is a maximum value, to a minimum one. Then by the time it reaches capital I1 here, okay, at that time you have an arrangement such that the device is in the on condition. Okay. So at that time you will be getting a continuous current. Or the other means to check whether the load current is continuous is, I'll calculate this I minimum equation. This your equation number 7. Equation number 7 of step down chopper with the RL load. Whenever I'll calculate this value, if it is positive or if it is greater than 0, then the load current is assumed to be in the continuous mode. Is it okay till here?
Yes, ma'am.
Okay. So then, first one was whether we need to check out whether it is continuous or not. Next, we have to calculate maximum and minimum values of I naught. So I naught maximum is again Vs divided by R into 1 minus e to the power minus of 2k divided by the tau whole divided by 1 minus e to the power minus 2 divided by k. Sorry. Yeah, 5 is 2. So 1 minus e to the power minus of 2k divided by tau whole divided by 1 minus e to the power minus 2 divided by k tau will give me this value minus of 24 by 1. This is e divided by r. I'll calculate this. The value is equal to 51.46. This is the maximum value of steady state output current. And this is a minimum value. Then the C value, what is to be calculated is average load current and peak to peak ripple current. Average load current we have to calculate. So for that, as the load current is continuous, the average output current is given by, okay, we have assumed that the current will be continuous. So the value is K into Vs minus E whole divided by R. Now I'll substitute the value of K, that is 0.3, Vs is 220 minus E, which is 24 whole divided by 1. 1 is your R value. If I calculate it like this, the value is equal to 42 amps. Okay, this is my average output voltage. Then peak to peak ripple current is delta Imax. So this delta Imax is nothing but it is equal to Imax minus I minimum. Normally in our derivations, what we have done is, I'll just explain it with respect to this. In our derivations, we have said that this value from here to here, whatever we have, this one, it is delta I. Delta I is nothing but this capital I2 minus this capital I1. So I2 minus I1 will be giving me the value of delta Imax. Here we have considered two values. One is called Imax and the other one is I minimum. So delta Imax will be equal to Imax minus I minimum. So it is 51.46 minus 33.03. I'll substitute and then I'll subtract. So the value is equal to 18.43 amps. Is it okay till here? Understanding? Is it okay with the problem? First problem? Somebody please reply. Am I audible?
Yes, ma'am.
Any doubts with the problem?
No, ma'am.
Okay. Second one is, we have a step down chopper and it is operating from a voltage which is equal to 220 volts DC source. Okay, Vs is equal to 220 here. And the load has R, which is a resistor, which is of 5 ohms and a very large inductance. Okay, so that the load current may be assumed to be constant at 22 amps. Okay, now in the previous problem we had calculated what is average output current or load current. Here it is mentioned directly that the load current is constant at 22 amps. Okay, if the chopper frequency F is 250 hertz, calculate the on period, off period and the duty cycle of the chopper. Okay, so what all we have is, we have what is called as I naught, that is the average output current. So from that we will calculate what is average output voltage and then we will calculate what is the duty cycle and then T on and T off as we know. Okay, first one is the average output current I naught, which is equal to 22 amps. Now I know what is average output voltage, which is V is equal to R into I. So V naught is equal to R into I naught. I know what is the value of resistor R. So it will be R into I naught. I'll multiply this I naught with R, that is 6 into, sorry, it should be I think I did a mistake here. It will be here, or else you change this value to 6 ohms. Okay. While writing here, simplification happen. Okay. So R is equal to 6 ohms and V naught is equal to R into I naught. So it is 6 into 22. So that is equal to 132 volts. Now we know what is V naught. So from the equation which is derived for your step down chopper, V naught is equal to K into Vs. Now I know what is V naught, I know what is Vs, and now I'll calculate what is K. So K is equal to V naught divided by Vs, rearrangement of the terms in this equation. So it will be V naught by Vs, which is 132 divided by 220, and the value is equal to 0.6. So it is nothing but 60% duty cycle. With this, we need to calculate what will be the turn on time and turn off time. Okay. Then, to calculate the total time period, I know what is the frequency. So it will be T is equal to 1 over F. So 1 by 250, that is 4 milliseconds. Now I want T on to be calculated. So T on is equal to K into T. T off is equal to T minus T on. Okay. If I consider this to be the total time period, okay, this to be the total time period and this is T on. Okay. Say this is my on period. So the other part will be off period. Okay. So to calculate what is the time period here or the off period here, what I'll do, I'll calculate this total time period T, and in that I'll subtract this T on. Okay. So T on is equal to K into T because it is ending at K into T. If you refer back to the waveforms, we have written the T on value as 0 to K into T. So T on is equal to K into T. So K value is 0.6 and then multiply that with 4 milliseconds. So the value of T on is equal to 2.4 seconds. Sorry, 2.4 milliseconds. Then the turn off time, that is equal to total time period T minus T on. So total time period T is 4 minus T on is 2.4. So the value is equal to 1.6 milliseconds. Hope you don't have any problem with this. Yes. Okay. Assuming that you people have understood the problem, I'll move on to the next one. So the third one is a thyristor chopper is supplying a inductive load. That means this is a RL load chopper with R value 10 ohms, L value 2 Henry. Okay. The DC supply to the chopper is 200 volts. That is Vs, which is equal to 200 volts here. If the chopper is operating at a frequency of 200, now this is equal to F. The on period and off period time ratio or on off time ratio of the chopper is 2/3. What is this now? This is the on off time ratio, that is T on divided by T off. So you need to calculate what is the average load current and also calculate what is the maximum and minimum values of load current in one cycle. Okay. Yeah, maximum and minimum, and then you need to check whether it is operating under a steady state condition. Okay. So to do this, initially what I have is, I will be writing down what are the given parameters. So the given parameters here are R, L, Vs, F, and then T on by T off. Okay, you'll write down all those things. Then we'll calculate what is called as duty cycle K. So we know from this ratio T on by T off. Okay. T on by T off is 2 by 3. I'll write it in a reverse order so that I'll get the value in terms of K. So I'll be writing it as T off divided by T on. So it is 2 by 3. So T off by T on will be 3 by 2. Okay. Now I'll add this T off by T on with 1. Okay. So when I add this, then I'll be adding 1 to the other side. So it will be plus 1. Adding 1 to the other side, what happens is you will be getting here T off by T on plus 1 and take the LCM. So it will be T on divided T off plus this cross multiplied. So it will be T off plus T on whole divided by T on. And this side it will be what? It will be with the LCM 2. I have this parameter becoming 3 plus 2 is cross multiplied. So the value is equal to 2. So this is total time period T. So that I have written. Down it is T on. Then this is equal to 5 divided by 2. So T divided by T on. We know that duty cycle K is equal to T on by T. That is the on period divided by the total time period, which is equal to the duty cycle. Now it is in the reverse order. So I'll be writing it in inverse. So T divided by T on is equal to 1 over K. Now I want what is K. So K will be the reverse of this, okay, or inverse of this. So it will be 2 divided by 5. And if I calculate, the value is equal to 0.2. Okay. So first we need to calculate what is called as the average load current and then maximum and minimum current. Okay. So then with this K value, and I know what is the frequency, I'll calculate what is total time period T. So T is equal to 1 over F, that is 1 over 200, which is 5 milliseconds. Okay. Then I'll calculate what is the time constant tau, that is L divided by R. L is 2 and R is 10. Yeah. L is 2 and then R is 10. So the value is 0.2 seconds. So this is the total time constant. Okay. Then this is a 0.2. Wherever I have a tau in the equation, I'll be writing this. And this I minimum, or you can write it as I1 equation. This is equation number 2 from the derivation. So it will be Vs divided by R into e to the power 0.4. 0.4 is K. 0.4 is K. Then multiply that with 5, which is the total time period T. Okay, 5 into 10 to the power of minus 3, that is 5 milliseconds, whole divided by tau. Okay, so 1 minus e to the power minus of T divided by tau. If I simplify this, the value is equal to 8.06 amperes. So this is, sorry, I think I was doing this. Yeah. I minimum is equal to Vs divided by R, e to the power 0.4, this is K, this is T, this is tau. K, T divided by tau. Minus 1 whole divided by e to the power K divided by tau. The value is equal to 7.94. You can see that the value is positive or it is greater than 0. So when it is greater than 0, it indicates that the load current is continuous. Okay. This is the first conclusion. Then the second parameter what I have to calculate is Imax. So Imax is equal to Vs divided by R into 1 minus e to the power minus of K into T divided by tau. 1 minus e to the power minus of capital T divided by tau. This is my Imax equation, or you can also call it as equation number 4, that is I2. Okay, capital I2. So this is, after we simplify, we will get the value as equal to 8.06 amperes. Okay, following till here?
Yes, ma'am.
Okay. Next we have the average load current. So average load current means I have two currents, I1 and I2, or I min and I max. So I'll be adding the two and then I'll divide them by 2. So it is I0 is equal to I max plus I min. So it is 8.06 plus 7.94. whole divided by 2. So the value is equal to 8 amperes. So this is the average load current what is flowing in the circuitry. Okay. So we'll move to the next problem, that is fourth problem. In a step down chopper, the DC input voltage is 600 volts. Okay, this is Vs, and the load resistance is 0.5 ohms, that is R, and the battery voltage is E, which is equal to 0 volts. Okay, the frequency of the chopper is 400, that is F, and the average load current is I0, which is 250 amperes. Okay, making use of the average load, making use of the average output voltage, compute the inductance, that is L, that would limit the maximum load current ripple to 10% of I0. Okay, so from equation number 11, that is delta Imax equation, we have written this value of L. So L value is equal to 0.525 into Vs into total time period T divided by delta Imax. Okay. So now I'll calculate what is T and I'll calculate what is delta Imax, and then I'll substitute because I know what is Vs. Okay, it is 600 volts. So initially T, which is 1 over F, that is 1 by 400. 1 by 400 will give me 2.5 milliseconds. Okay, this is my total time period, and I know IE is equal to 0 and Vs is equal to 600 volts. Fine. So delta Imax is equal to this 0.1 into 250. So this delta Imax is equal to 0.1 into 250 is nothing but it will it will be actually Imax minus I minimum. So in this particular case, we can calculate it as 0.1 into 250. So the value is equal to 25 amperes. Okay. Now what I'll do, I'll substitute the values. L is equal to here 0.25 into Vs into T whole divided by delta Imax. So 0.25 into Vs, that is Vs, which is 600, then into T, that is 2.5 milliseconds. So 2.5 into 10 to the power of minus 3 whole divided by 25. So after I do this, I'll be getting the value of inductance as 15 millihenry. So what we have in the question is, we need to be computing the value of inductance L that would limit the maximum current to 10% of I0. So 10% of I0 is, here we have 250 amperes. So 250 amperes, 10% will be 25. So we will be doing this as 25. Okay. Following this,
Yes, ma'am.
okay. Any doubts still here?
No, ma'am.
No? Okay. So we'll do one more problem. Here what we have is a step down chopper feeds an RLE load. Okay. Normally they'll be mentioning the step down chopper or step up chopper. Otherwise they will give you the circuit diagram. So based on the circuit diagram, you need to identify whether it is a step down chopper, step up chopper, or it will be a step down chopper with RL load, step up chopper with RL load. Okay. So what we have to do is, every time whenever we get a problem, then we need to analyze whether it is a step down chopper, step up chopper. Okay. Then you need to start it solving, because the problem, in the derivation part, every different circuit has a different formula. Okay. So a step down chopper which feeds an RLE load from a 250 volts DC source. The duty cycle of the chopper is K, which is equal to 0.3, and L value is 0.3 Henry, R is 0, and E is 75. Okay. Now we know what is duty cycle, we know what is the voltage source, we know what is the load parameter, that is R, L and E values we know. We need to determine the chopping frequency F, and we need to determine the peak to peak ripple current in this particular case. Okay, so initially write down what are the given parameters. It is Vs, L, R and then E followed by K. So initially we have K is V0 is equal to K into Vs. Write down what is V0. So K is 0.3 and Vs is 250. Multiply, you will be getting it as equal to 75 volts. Okay, during on period we have written this as L into di1 by dt plus E is equal to Vs. Okay, this we have written while deriving. So during the mode 1 it is. So di0 by dt, which is equal to 250 minus 75. Yeah. So 250 minus 75. 75 is your V0. So the value is equal to 175 volts. Okay. And we assume that R is equal to 0 because it's mentioned in the equation. So di0 by dt is equal to delta I divided by T on. Okay. So we can also equate this to L into delta I divided by T on. This di0 by dt is equal to delta I. So L into delta I divided by T on is equal to 175. Now I want only T on to be calculated. So I'll rearrange this. So I'll be taking it to the other side. So L value I know it is 0.3, delta I it is the 5 amps. Okay. So 0.3 into 5 divided by 175. So the value is equal to 8.57 milliseconds. Okay, this is what it is T on. And we know that K, that is duty cycle, is equal to T on divided by total time period T. Okay, so from this, yeah, I know what is K and I know what is T on. So I'll calculate what is total time period T. So total time period T is equal to T on divided by K. So substitute the value 8.57 into 10 to the power of minus 3, that is milliseconds. Hold it divided by 0.3. So the value comes out to be equal to 28.57 milliseconds. This is the total time period T. I want F. F is equal to 1 over time period. So 1 divided by 28.57 milliseconds will be giving you 35 hertz. Is it okay till here?
Yes, ma'am.
Is it okay?
Yes, ma'am.
Okay. So, yesterday class we have done problems on step down chopper, step up chopper with R load. Today's class we have done step down chopper with a RL load. Okay, and we have calculated what is capital time period T, what is duty cycle K, what is delta I max, what is capital I max, capital I min, as well as we have also calculated what is the inductance value, that is L, and we have seen what is to be calculated for T on and T off if it is not mentioned in the equation, and we have also seen how to calculate delta I max when we know the value of R, L, E and T on and T off. So all varieties of step down chopper with RL load we have solved it today. So in the next class we are going to cover about the buck regulator, boost regulator. No, before that step up chopper with loads. Step up chopper with a RL load we have to do, and after that we'll be covering the buck regulator problem, boost regulator problem and buck boost regulator problem. Okay. Till here, no doubts?